We left off talking about orthogonal curves, and on that note, all of our recent meetings are on Canvas now, and they'll stay on Canvas. Okay, so orthogonal curves have tangent lines that are perpendicular at points of intersection. We want to show the two curves put them up here in a second. It's going to be x squared plus 3y squared equal to b, and the other one is y equals ax cubed. We're going to show that they're orthogonal. The other one is y equals ax cubed. So we're going to find the tangent lines for each of those curves. We're going to find the slope. We just need the slope of the tangent line for those curves, and then check that one slope is the negative reciprocal of the other slope. That means they're perpendicular lines, which makes them orthogonal curves. So let's just restate this part. Take a derivative of both sides. So we can even write d dx of each of the sides. Okay, we're going to try to make it through this problem at least. We're still recording, and I just want to stop and thank you for being so patient this semester. I will make sure that we can make it through all the information and homework we need to do. All right, if we lose connection again, we will wrap it up, but let's try to do this. The part we want to be concerned about is this value y is a function of x, so make sure you use the chain rule when you do the derivative. Oops. All right, we're here. 2x. Add 6y to the power 1. and then apply the chain rule, so multiply by y prime. B is a number, so when we do the derivative, this is now equal to 0. We're going to solve for y prime. Right here, it's just simplify negative x over 3y. And right here, from the other part of the problem, we're plugging in what y was. We had that y equal to ax cubed. Remember, that was given to us with the problem. Negative 1 over 3ax squared. Now we look at the other curve, which was y equals ax cubed. Find its derivative. And we're just going to even write it down. d dx of y equal to d dx of ax cubed. This should be pretty fast. Okay, so this would be y prime. And we would have 3ax squared on the other side. And we're good to go. I just want to make it clear that the other slope, it was a negative 1 over 3ax squared, is negative reciprocal of that slope. Then the slopes of the tangent lines are perpendicular. Or then well, since the slopes of the tangent lines are negative reciprocals of each other, the tangent lines are perpendicular. So these are orthogonal curves. Okay, we're still connected, so I'm going to try to do some more notes. We'll see how far we get. But I've just got like 2 pages left. The next part is to find higher derivatives. Oh, implicitly. So We start with y equal to f of x. Then the derivative is y prime. You could put y or you could put f of x. I put f prime of x. Okay, then take another derivative. So taking the derivative of y, then the derivative of that. And it's written d squared y over dx squared. So it's been a while since we've kind of talked through this notation with someone, but I'm pretty sure you're looking at like this part, the derivative twice of your function y. Right, f double prime of x. We'll do one more, and then we'll practice. Y triple prime b d cubed y. Okay, so I have an example that we started last time. We did the derivative at least once, and then we'll try doing it again. Doing the second derivative. Okay, the function. We looked at. It's an equation where you have x squared plus y squared equal to 4. Okay, we've already worked through this at the last meeting we had. So I'm going to write down what we got. It was y prime equal to negative x over y. We want to find y double prime. Okay, take the derivative. Let's see. I did d squared y over dx squared. Would be the derivative of y twice. Would be. Let's see. We're going to need a quotient rule right here. Let's call this I like to call the top function f, and then the bottom function is going to be g. Let's do this color. Let's see. So the top function will include the negative sign in there. Okay. So we have g times f prime minus g prime times f divided by g squared. times the derivative of the top, -1. Subtract the top function multiplied by the derivative of the bottom function, which would be y prime. And it's over y squared. Let me check this here. I've got -y, yep, plus, okay, let's get there. -y. Add x, y prime is over y squared. I think that's it. X times dy dx. Oh, we can do some more. Cool. We know what this is. So we're going to put in y prime and then get this even further simplified. All right. -y add x times y prime, which was equal to -x over y. And everything's over y squared. So we've got a -x squared over y in that numerator. And now let's even split this up, reduce both terms, and then be done. So instead of dividing by this, we're going to multiply by 1 over y squared, where it's the same thing. Okay. That was the goal for today, and I think we're just going to call that the end of section 3.5. So right now I'm trying to make, we're done recording.